Good morning, dear student. I am Rupak Shah from the Millennium School, South City, Lucknow. Today I will be giving the lecture number 6 for the chapter Motion. Before I start the today's content, I will take a small recap of the previous lecture, which is given as follows. First, the average speed is defined as the total distance upon total time. In case your distance are different and the times are also different, in that case we use the formula total distance upon time, and that is called average speed. Second, acceleration is defined as a rate of change of velocity, which can be written as change in velocity upon time, or we can rather use increase in the velocity upon the time, because normally the acceleration is used for the positive term. So a is equal to v minus u upon t. Symbol here used here will be a, and SI unit is meter per second square. Third is called retardation. Retardation is called decrease in the velocity upon time. Symbol used will be minus a. SI unit will be the same. Just always follow that acceleration is normally trend used for the increase in the velocity, and retardation is for negative acceleration, so it is used for decrease in the velocity. So by this time I must understand that all this topic should be clear to you, and any other queries are there that should be conveyed to us during the Zoom session. So today we will be starting with a new concept that is called conversion of kilometer per hour into meter per second. Dear student, it is very important to convert kilometer per hour into meter per second, because kilometer per hour is not the SI unit of speed or velocity. So we need to convert them into meter per second, which is very important. So I am showing the steps and easy methods also. I am giving examples, just follow them 2 or 3 times. 36 kilometer per hour. 36 convert kilometer, if you want to convert kilometer 1000 meter, and hour 60 into 60 3600 seconds, that you already learned in the junior classes. Step I have already shown here also. 36 multiplied by 10 into 10, that is 1000, and 60 into 60 minutes into 60 seconds. So 0 get cancelled, you're left with 10 upon 36. Further simplifying, you get 5 upon 18. So in other words, we can say we have to directly multiply 36 into 5 upon 18. And if you further simplify them, you get an answer 10 meter per second. So what you have to follow, that if you want to convert kilometer per hour into meter per second, directly multiply 5 upon 18. That's a very easy step where you can find your answer in meter per second. Let us take one more example. 54 kilometer per hour into meter per second. So what you are going to do? 54 multiplied by 5 upon 18. So 18 cuts the 54 by 3. So 3 into 5, you get 15 meter per second. So I will show you in the numerical practices when we take the next one. But for this now, this topic should be clear now. Now we already read that to convert kilometer per hour into meter per second, multiply 5 upon 18. But if you want to do in reverse, meter per second into kilometer per hour, we do the reciprocal of it, that is multiplying 18 upon 5. Dear student, you have followed that if you want to convert kilometer per hour into meter per second, you have to multiply 5 upon 18. But if you want to convert meter per second into kilometer per hour, you need to take the reciprocal, that is 18 upon 5. So it is 18 upon 5, and you should note that we must convert kilometer per hour into meter per second, which is the SI unit for velocity or speed. Otherwise we cannot use them in the numerical. Now I am taking one numerical for your better understanding. You will understand how I have used it in a numerical and how I have applied them to get the value of acceleration. So I am reading the question. If a body increases its velocity from 36 km per hour to 54 km per hour in 5 minutes, what is the acceleration in meter per second square? Now you must follow that this 36 which is given is the initial velocity, but in kilometer per hour. Here 54 which is given is final velocity, but again it is given in kilometer per hour, and again the time is also given in 5 minutes. So we have shown some simplified step in which way you will do. Initial velocity is shown by the symbol u. 36 km per hour. I told you we have to multiply 5 upon 18. 18 cuts the 36 by 2, so you get 10. 54 also I told you 54 multiplied by 5 upon 18, 18 cuts 54 by 3, so you get 15. So U and V already you get in meter per second. But what about the time, which is in minute? So we have to convert that in also in seconds. So multiply 15 minutes. In each minute there is 60 seconds. So 5 multiplied by 60 you get 300 seconds. So all this value has to be put in the formula. So A is equal to V minus U upon T. V is 15 minus 10 upon 300. Time is 300. So 15 minus 10, 5 upon 300. Simplifying 1 upon 60. You can rather write 1 upon 60 or you can get it in decimals. So these steps should be clear when we are doing the calculation for acceleration, especially when the units are given kilometer per hour. Otherwise our calculation will go wrong, our results will go wrong, and these steps will be not acceptable if you are applying the kilometer per hour values. So we need to convert them into meter per second. We have to do in the same way that is shown in the way. We'll do further numerical practices in the coming lectures. Don't worry for them. But at this moment, observe this video for 2-3 times. Try to practice them in your home. Find that what difficulty you're finding, where the steps has to be used, and how you're getting the value. Please check them at least 2 or 3 times. That can enhance your numerical ability, and also practice will make you more perfect. I hope it is clear now. So we are moving to a very small topic which should be known for graphical representation. This topic is called uniform acceleration and non-uniform acceleration. Please follow them. These words are very, very important as far as graphical representations are concerned in the coming videos or coming lectures. If a body increases its velocity equally with equal interval of time, it is called uniform acceleration. Please follow the words that I am using. If the body is increasing the velocity equally, for example, you are in a highway and we are increasing our velocity equally with equal interval of time. Let us take an example that we are increasing our speed from 0 to 10 meter per second in first second. In the next second we are increasing to 20 in 1 second. Again we are increasing to 30 in 1 second. It means every 1 second we are increasing the speed by 10 meter per second. Initially we have done 10, next again 10 to 20 means 10, 20 to 30 means again 10. So if you show it by graphically also, the first 10 meter per second is done in 1 second. When you go to 10 to 20, again it is a gap of 10. How much time is taken? 1 second. Similarly again 10 meter per second, that is you have gone to 30. Again you have gone to 40, 50. So every time the gap is same, equally, and time is also same. And if you plot the graph, you get a straight line. So it has to be followed that for a uniform acceleration, we have to increase our velocity equally with equal interval of time, and the graph obtained in that case will be a straight line. So I hope this particular topic is clear with everybody. So now we are coming for non-uniform acceleration. Now if you define non-uniform acceleration, how we are going to define it? If a body increases its velocity unequally with equal interval of time. Now you have seen we are increasing our velocity unequally. It means that you are not increasing your velocity equally. Means, for example, 1 second your velocity comes 0 to 10. In the next 1 second it becomes 12. In the next 1 second it becomes 20. It means that you are increasing the velocity unequally. It is not 10 every time in a 1 second. In that case, the acceleration cannot be called as uniform. Your acceleration will be called as non-uniform acceleration. So these terms should be clear, and when we plot the graph, we get a graph between V and T. Please understand, this is a graph between V and T. Let's take this graph once again. The V is taken along the y-axis and time is taken along the x-axis. So we are plotting the graph between V and T, not S and T. So if you plot the graph between V and T, then we get a straight line. And similarly, if you plot a graph between V and T in non-uniform motion or non-uniform acceleration, then the graph comes curved line. It is not going to be straight line. So these graphs we will take in details in the next lectures. But before we take the next lectures for the graphical representation, it's very important to understand these terms clearly. Otherwise, we cannot understand the graphical representation, in which way we are going to take the VT graph, in which way we are going to take the ST graph. It's very important, at least to understand these values or to understand these particular terms: uniform acceleration, non-uniform acceleration. And similarly, if you want to define uniform and non-uniform retardation, just follow my words what I am using. Uniform retardation, if the body decreases its velocity equally with equilibrial time. It means when we were using the uniform acceleration, the velocity was increasing equally. But when we are taking uniform retardation, body is going to decrease the velocity equally with the time. So there is only the difference of increase and decrease. And similarly, if you want to define non-uniform retardation, then you can write non-uniform retardation if the body decreases its velocity unequally with equal interval of time. So you have to understand, when we are using the acceleration term, it is increase in the velocity, and if you are using for the retardation, it is decrease in the velocity. Otherwise, uniform is equal and non-uniform is unequal. So that particular definition should be clear to you. Whenever we are using it, the graphical representation should be also clear to you. And all these things we are going to apply in the graphical representation next time. So you should not have any queries, any doubt regarding all these topics. Go through these videos at least for 2 to 3 times. I told you, dear student, these are the concepts which are very confusing and very analyzing type or applied type. So you need to understand them. They are very important for your syllabus and very important for your subject. So you should be clear about all these things. One thing I must tell you, that by this time I told you that you should be joining your Google Classroom, because Google Classroom will be posting your homework now on the regular basis. So at least if you are posting it on Thursday, you are supposed to submit it by Saturday. So there will be a time frame given to in Google Classroom. So it is your advice to join the Google Classroom as soon as possible, so that you can make your homework and home assignment updated. So in case you are facing any problem, you can talk to me or talk to your subject teacher concerned. And in case even if you are not able to post it by Google Classroom, it should reach to us in our email given to us. But it is the first priority that you should post it to the Google Classroom, so that we can easily see your assessment or easily see your performance. I think this is enough for you. Thank you so much.